All right, guys, so now we are on section 12b13, and I am going to correct question number 3. Question number 3. On this question, actually, I'm going to just stop to Q3. I'm going to put that question number 3. And you have to write in scientific notation 5, and you got 1, 2, 3, 1, 2, 3, 1, 2, 3. And in scientific notation, this is 5, 10 to the 9. All right, now question number 6. Question number 6. On this question number 6, we need to write the number in standard notation. So we have a 8.5 times 10 to the negative 2. 10 to the negative 2 means that if you, how can I write that like this? So 10 to the negative 2 is that you're going to have 0.085. Because when you are at 1 over 10 to the 1, which is 1 times 10 to the negative 1. This is coming from the rule of exponent. 1 over a to the n equal a to the negative n. So when you have 10 to the negative 2, it's exactly if you were divided by 100. So therefore, your 8.5 multiplied by 10 to the negative 2, it's like if you had 8.5 divided by 100. And so you are going to move to the left your period 1 times and 2 times. All right, problem number, let's see. Problem number 10. Problem number 10. Problem number 10 is about doing an experiment. The following time in seconds were recorded. We got 7.5. We got 6.6, 7.2, 4.4, 6.6 again, and 6.7. And you need to find the mean. The mean is going to be, the mean, usually notice with a bar above, it's going to be the sum of the data divided by the number of data. So in that case, the mean is going to be 7.5 plus 6.6 plus 7.2 plus 4.4 plus 6.6 plus 6.7. And I will have to divide by 1, 2, 3, 4, 5, 7. 1, 2, 3, 4, 5, 6 number. All right, I will let you finish the calculation. All right, problem number problem number 16. All right, so on this problem number 16, what do we have? Use the product rule to simplify the expression. So you have y to the 10 times y to the 8. This product rule says that basically when you have a to the n times a to the m, it's going to be a to the n plus m. You have the same base. You add the exponent. So this is what you have right here. You have the same base y. So the answer is going to be y to the 10 plus 8. So the answer will be y to the 18. Problem number 16. And let's try to do problem number 21 or 20. On this problem number 20, we have p to the 9, q to the 6 over p to the 6 times q cubed. Use the quotient rule to simplify the expression. So basically what you have right there, it would be a times b over c times d, which can be rearranged the way you want. It could be a over c multiplied by b over d, but it could be also a over d multiplied by b over c. So what you can seek right now is, first of all, you have only multiplication between the terms on the top and between the terms on the bottom. So you can literally reorganize only the p together, p over 9 over p over 6, multiplied by q over 6 over q cubed. Using a rule of exponent, you know that you have two different choices. You could have, let's move on to the p over 9 over p over 6. It could be p multiplied by p, multiplied by p, multiplied by p, multiplied by p. 9p, 1, 2, 3, 4, 5, 6, 7, 8, 9, divided by 6, 3, 4, 5, and 6. And then I can simplify the p together. P over p, p over p, p over p. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. At the end of the day, the answer will be p cubed. But if you have to use your rule of exponent, like they suggest, you need to remember that, again, I would like to rewrite that again, 1 over a to the n equal a to the negative n. So therefore, p over 9 over p over 6, which is p over 9 multiplied by 1 over p over 6 to the 6, it is basically p to the 9 multiplied by p to the negative 6. And what did we say? We said earlier that when you have the same base and you need to add the exponent a to the n plus m. So in that case, I'm getting p to the 9 plus negative 6. And 9 plus negative 6 is going to give you p cubed. So I got exactly the same thing. So I will do exactly the same thing for the other one. And so p over 9 over p over 6 multiplied by q to the 6 over q cubed is going to be p cubed. And q to the 6 divided by q cubed is going to be q to the 6 plus negative 3. And it's going to be q cubed, which could be written as pq cubed. All right, guys. So I think I have covered pretty much all the problem. What I really want you to re-insist, let me try maybe to go over problem number 18. I want to do another one last problem number 18. On this problem number 18, we get b to the 13 times c to the 5th in between parentheses multiplied by b to the 12 times c over, no, there's no over, and use the product rule to simplify the expression. So basically, what do we have? We have a multiplication right here, right? So I can decide to get rid of my parentheses. I could have b to the 13 times c to the 5th times b to the 12 times c. I can reorganize to have the b next to each other. B to the 13 multiplied by b to the 12 multiplied by c to the 5th multiplied by c. And now I could have my two parentheses right here. And if I do so, I have the same base, right? B to the 13 and b to the 12 and c to the 5th and c to the 15. So if I have the same base, I can rewrite only one with the sum of 13 plus 12, which is going to be 25, multiplied by c to the 6. Okay? So remember your rule of exponent. They are extremely important. And you will recognize that every single time you don't know how to do something, it's because you don't know your rule. So pay attention when you are going to write your note. Pay attention when you're going to write your flashcard. And try to memorize. And again, memorizing doesn't mean that you necessarily understand right away what is going on. It's really trying to remember it. And you will not remember them by just doing the problem. Before to do the problem, you must absolutely spend time trying to remember your rule of exponent. Let me try to recapitulate a few of them on the side right here. You got a to the n times a to the m, same base. You need to add the exponent. A to the n all right, a to the n sorry, here we go. One over, here we go, finally. 1 over a to the n equal a to the negative n You have a to the n to the m. It's going to be a to the n times m, but a to the m to another exponent m. That's pretty much it. Okay, so if I forgot some of them, I will go back with you in class. Thank you very much.